Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender Systems. I don't know about you, but I've always felt like my interests were a bit niche. Astute listeners would probably be aware I'm a fan of ska music, and some of you right now are saying, what is ska music? Well, a passable example is our theme song for this season. It's a cover song by Run and Punch, one of Chicago's greatest active ska bands, and the title of our theme song is called We've Never Met. And that makes me think about the content I would like to meet. I don't need to be recommended a fast food restaurant that's on every block. I want to be recommended some niche place only locals know about. When it comes to news, I'd like to get some ska news, some tech news, a touch of world news, of course. But for the average person that doesn't mind vanilla ice cream, plain pizza, blockbuster movies, and pop songs, you can just give them kind of any old popular recommendation. This leads to something called popularity bias. That simply because something is broadly popular, which might mean it's kind of generic, on average it's going to get the most upvotes, favorites, or other sorts of signals that systems need to help determine the quality of content. Serving niche content to those users that want it is one of those really hidden challenges in recommender systems. Our guest today, Vaclav, is a machine learning researcher working at one of the largest internet companies in the Czech Republic. Vaclav is on the front lines of building personalized news recommendations for millions of users. And in this interview, we're going to explore how recommender systems can unintentionally amplify popularity bias, and what it takes to give the long tail of content a chance to shine. Stay tuned for some practical insights on combating this popularity bias, designing fairer recommender systems, and some good notes on the intersection of machine learning, user behavior, and business strategy.
My name is Václav Blahut, and I'm a machine learning researcher at Seznam.cz, which is a Czech internet company. I've been doing this for more than 6 years now. Yeah.
And if you wouldn't mind sharing, what's your academic background?
Oh, yeah, perfect. I have been studying artificial intelligence and natural language processing at university. I finished my master's 6 years ago, and I started working at Seznam right after. And the university was Masaryk University in Brno, Czech Republic.
You picked like a perfect time to be studying that field. It was growing leaps and bounds, in my opinion. Do you have any just general thoughts on the transformation of NLP that you've observed in your career?
Yeah, definitely. I have to say, from what I've learned at the university, I applied almost nothing, like only the very basics. And from then, once I started working in the industry, it completely changed. I started working at the very right time, and all the BERT-like models arising were a huge breakthrough. So I didn't really get to try all the cool stuff that I learned at the university, just the FIDF, and then go straight to BERT.
Yeah, it's a good step. BERT's a powerful tool I still use. Well, when did you first get interested in recommender systems?
Yeah, I did take some courses at the university, but then it kind of fell into my lap when I was looking for the job in the area of machine learning. I just had a friend at this company, Seznam.cz, and she recommended me as her roommate. And at the moment, there was this free opening for a researcher of recommender systems, so that's what I jumped for.
And what sort of transition is it to go from studying machine learning to focusing in recommender systems?
Yeah, as you say, it's definitely focusing on this specific topic. So I did probably forget half of the stuff that I learned at the university, just because I don't use it in this field. And well, the most special thing was definitely that we have the actual data from production that I can play around with, which was a dream at my study times to have this kind of data.
Definitely. Yeah, there's Movie Lens and some other popular things that come up a lot in recommender system circles, but there's nothing like a real world application to get some real data on.
Exactly. Yeah.
Could you share a few details on what sort of real world data you have access to?
Oh, yeah. Our main playground that I usually work on is this newsfeed at the seznam.cz homepage, which is like the homepage of Czech internet, and many people use it around here. And the data consists of user interactions. We of course know what we have recommended to the users. Then we receive some clicks and maybe the time that the user has spent consuming the item, like reading an article or watching a video. And then we also do have some more explicit interactions like likes or removes. That means when someone dislikes some content, then they can just click this button and hide this content. So yeah, that's the kind of data I'm working with.
Well, when it comes to news, sometimes there's a big news story. Like I imagine the first time a human walks on Mars. That's going to be everybody's headline. What a sensational story. But on the average day, there are some popular stories and some maybe more local or less popular stories. Do you face any challenges in determining what you want to serve the users?
Definitely. Yeah. Well, our machine learning pipeline does it for us, kind of, and we just have to take care of it and observe what it does and maybe fine tune it a little bit. And it does it for us. But as for the some major headlines of the day, there's the thing that homepage consists of some like content boxes that usually do contain those headlines. And this news feed at the bottom of the homepage, that is our playground, is usually less focused on the current news, and it's more into like entertainment and some niche content and stuff like that. So we don't explicitly regulate how much of the current news appears in the news feed. Yeah, it just happens naturally.
Are you focused on something that does personalized recommendations, or does it generally find something that works for everybody?
Our recommender system is definitely personalized if the user allows us to, if they consent with using their data, and preferably if they're signed in, then we do personalize the content that gets recommended to them. But we, of course, need to tackle the problem of cold starting new users or serving those users without consent. So then there are some different branches of how the recommendation works depending on the situation.
Sure. I imagine you hit that cold start pretty often, that here's a new user or they haven't signed in yet, haven't yet created an account. Hopefully they will, so they get better results. But a lot of people, in most cases, they're showing up for the first time, at least from their digital fingerprint. What's the best you can do in that case?
Well, our typical recommendation for cold start users consists of mainly some bandit algorithm generated recommendation. That means that we cluster the items into some number of clusters just to make the recommendation somehow diverse. And then we sample using bandit algorithms from those clusters, just not to overexpose some specific popular part of our catalog. And then we also do serve some completely random recommendations just to have better data.
Well, the main paper I invited you on to discuss is titled Bypassing the Popularity Bias, Repurposing Models for Better Long Tail Recommendations. So, a couple things to unpack. First off, could you give us a definition of the popularity bias?
Oh, that's a tough one. Well, popularity bias is a phenomena, in my words, that is to some extent natural, that some type of content is generally more likable by a larger group of consumers than some other niche type of content that only is attractive to some very minor groups of consumers. And that's natural. But the problem of popularity bias in recommender systems is that typically the models, machine learning models in recommender systems, amplify the problem of rich getting richer and poor getting poorer, meaning that the popular content gets recommended even more, even though it may not be as relevant to the user as some other item.
So one could argue that if something very popular, it's popular for a reason, right? It got all these clicks, it got all this attention, people are spending a lot of time on the page. What are they missing out, though, by not getting some other recommendation?
They're missing out on the niche content that might fit them better in the end, that might be more interesting. Maybe they would gain some knowledge from reading this article or watching this video. And on the opposite side of the table, there are also publishers of this content that may not thrive because their content is too niche, and just because they write about something very interesting but very niche should not be a reason for them to go bankrupt, let's say.
Sure. Yeah, on a personal level, I feel like I'm more interested in niche things, less than like what's super popular. Like, I don't want a Coca-Cola. What else have you got? You know, that kind of thing. But at the same time, I know niche content is quite a long tail, and there will be certainly some things that interest me and some things that don't. How can you help algorithmically surface the good ones, or the good ones from my perspective?
Mhm. Well, that's a tough problem. Yeah, we have mastered the mainstream recommendation, I would say, pretty well. The recommendation of the long tail items is more complicated. So we have to think differently when we want to recommend niche content to the users. And one of the options to do this is described in the paper. To begin with, we need to completely change how we look at the recommendation. Say we have some niche content produced by some publisher that doesn't get enough attention, and this publisher produces a nice new article about something very niche, and we need to, instead of recommending this item to the user the normal way, we need to somehow determine whether the user is the right user for this item. So it's completely switching how recommendation work. Instead of recommending items to the user, we are now looking for the right users for this given item.
So, yeah, one alternative you could do would be to say, okay, we have a niche item. Let's just show it 1,000 times to the general population and see if it gets any traction. How does your method get an advantage over something baseline like that?
Well, we actually do this baseline thing as well. What you described is our standard cold start technique to just kickstart the item and gather at least some data, even though there will be almost no clicks. It's still something. We can still learn something from this. And we do this even with the long tail items. But still, the long tail items usually do, as I said, get only very few or maybe sometimes even no clicks at all. And at this moment, we need to switch and start doing the inverse recommendation as I described it.
So, can we zoom in on that inverse recommendation? So, instead of recommending an item to a user, you're recommending the user to the item. I can kind of conceptually get how that works, but then in practice, I'm a user, I'm logging in. How do you go from those, items that would say, "Oh, I'm great for this person"? Maybe there are a couple items all raising their hands. How do you pick who wins?
Mhm. Yeah, the items are stored somewhere. This inverse recommendation is a batch process that runs periodically. So we always compute the new set of the right users for an item. And those users get stored in some key value database. And once the user visits a homepage, we just have a look in the key value database and recommend it to the user. We do not display only those items. It's actually an endless feed of items, so we just insert it into the feed at few positions so we don't overfill it.
Sure. Well, everything conceptually makes sense and is very intuitively pleasing. But of course, you want to measure it in some way and say, does it actually have the success we expect? How do you go about measuring?
Oh yeah, we have conducted series of A/B tests. We always perform A/B tests that are run online for some predefined amount of time. Those A/B tests are randomized. The unit of randomization is the user, and those users that have been given the treatment are then evaluated, or their experience is evaluated in terms of click-through rate. Is our typical number one metric, of course. Then the time that the user has spent consuming the items is one of our other metrics. But very specifically for this approach of inverse recommendation, we have had to select more specific or more special set of metrics. And so we need to somehow capture whether or not those items have actually been recommended to more users or not, and how well did the model perform. To capture whether or not we have delivered enough exposure to those items, we have decided to use a metric called bottom 50% share, which captures the overall share of exposure of the bottom half of the items ordered by their popularity in ascending order.
Well, depending, I know you're dealing in news articles, so maybe those are more clean, but if it were broadly like user generated content and you look into the long tail, sometimes you find cases where someone just posted like the letter M 50 times for unknown reasons. Do you face challenges like that, or is your data set pretty clean?
Well, we do, yeah. We don't recommend user generated content at the moment, but we still do encounter problems where the content just does not stand up to our expectations. Or just to reverse it, we actually do not employ this inverse recommendation on all of the publishers. There's just a small subset of publishers that does get this treatment. And yeah, one of the conditions for a publisher to be given this treatment is that their production tends to our standards and that the content is the niche content. We have to have some classifiers for this. And also the selection of the publishers is based on historical data, on the historical revenue of the publisher and the number of clicks or impressions per item, click-through rate, and a few other criteria.
So I imagine it would be good to see that that bottom 50% gets more exposure through this process. Do you have any metrics on that?
Yeah, that was the bottom 50% share, and we were expecting an increase in this metric, and we did get increase in this metric. And then there's also another metric called percentage of sufficiently exposed items, which is kind of complementary metric to this one. But instead of focusing on the whole bottom half of items, it's focusing only on those items that actually did get the treatment. So it shows something a little bit different.
Well, there's something very appealing about that. It's sort of egalitarian. Can we bring up, a rising tide lifts all ships? Can we bring up the bottom 50% and get them some exposure? But of course, that has to be a balancing act. You could show only the bottom 50% and fix it pretty quick. How do you balance between your more traditional recommendation approach and trying to do some boosting?
Yeah, this was definitely a business decision, but I believe we came to some sweet spot where the cost in terms of KPIs, because of course, doing this, replacing some possibly more attractive item with one that is more niche and possibly less clickable. Of course, this does cost us some KPIs, such as the number of clicks or the click-through rate overall. But yeah, that is something to balance out, and this was a business decision to be done.
Makes sense, yeah. I would think, though, that you would see an increase in click through rate as you're surfacing. Maybe sometimes it's a random niche item, but if on the occasions when you do connect, I would be maybe more than likely to take an interest in an article that fits my niche rather than some general article. Do you see an uptick in that regard?
Well, the thing is, the overall click-through rate did suffer a little after deploying this approach to production. But in long term, we believe that this will have a good effect on the overall user experience.
I think there's a way, from my point of view, you could say that even if I don't click on something, I, at least personally, want to see a diversity of articles. So maybe it's not something that interests me, but I want to feel that I've gotten a good selection. So in that regard, maybe another metric could surface that would highlight, that the user's appreciating this process, even if the clicks don't resolve, perhaps.
Yeah, we did, of course, do a lot of research before we dove into implementing this solution, but we did struggle to find the right metric to really capture something like this. We have observed an increase in diversity in terms of number of unique recommended items, but there's definitely still more to be measured.
So I don't know your company in particular, but I have personally observed a lot of companies that get stuck on the topic of recommendations because they get something either good or good enough, and there's a fear to change or a fear to experiment. And sometimes you have to convince the stakeholders that it's worth doing some experimentation and some testing and things like that. Did you face any challenges in driving things out to production?
Really grateful for my managers and supervisors that this project did get its place, and we did have time to work on this and do it at least somehow properly. And that in the end, that even the fact that we have lowered the KPIs non-negligibly, it's still it was still go from them.
Very cool. Well, I know pretty much every context in which you want to roll out a recommender, you're going to face the long tail problem of content, that there's always a lot of popular things, and then maybe one could argue the most interesting things are the niche things in that tail. Do you, having gone through this process, do you have any recommendations for people in other industries or at other places who could take learnings away and improve their approach?
Okay, my view on this is that we should always combine multiple approaches to get the best results. In our specific case, we do have some main recommender pipeline that does the personalized recommendation, but then we also employ some other approaches. Now we are actually working on this purely content-based recommendation that is completely shielded from all kinds of popularity biases. And we just mix the items recommended into the same slate of recommendation and display this to the user. And yeah, that's my message.
And do you have any advice for, I guess, A/B testing approaches? I think earlier you'd mentioned like it's like a feed, so it's theoretically infinite. I imagine you've played around with that at least a little bit. Do you know what works best?
Yes, I I can't tell what works best, but what works
Fair enough.
what works best for us, as far as we know, is also to personalize it, to really observe whether the user maybe prefers the mainstream recommendation. So we just use mainly typical recommender system. Maybe we observe that this current user is more interested in the niche content, so maybe we do put more items from this content-based recommendation or from the inverse recommendation. And yeah, so personalization definitely is the way.
So I'm personally somewhat privacy conscious, but I also want good recommendations. So I'll definitely hit that accept cookies button if I think I can get better recommendations. Is that enough, or should I really log in and create an account?
In our case, it probably depends on the browser you are using. If you
Hmm,
accept the cookies and you don't have any like a cookie cleaner, then you don't have to log into our main site. Still, probably you would miss some parts of the service if you were not logged in.
sure. Well, if I am logged in and I have a history that you can look at that has sort of the promise that machine learning can pick up on patterns and maybe recommend niche things to me, but in that cold start problem, is it hopeless? Is there anything you can do?
The optimal way I would go is to start with something like we do, the clustering, and then using the bandits algorithms. And maybe also include some of the randomized recommendation. And slowly, as you would start using the service and collect some history, maybe we would start to insert more and more personalized content from the main models. Yeah.
Makes sense.
And this way, we would shift from the non-personalized, just fluidly switch to the personalized.
And you'd mentioned that there were some business decisions involved. I think that's pretty typical because always the business has to look at the bottom line and its other objectives. But there can sometimes be a challenge there that for all of the methodology and the machine learning and things like that, the business might need a simple knob or a lever, something, a theoretical kind of user interface they can tune, what maybe we'd call hyperparameter tuning, but they want to set a knob. Okay, we're going to have more preference for long tail publishers this week or less preference or something along those lines. Do you have any thoughts on designing systems that are suitable, that the business will appreciate and get delivered in a mechanism that they're comfortable with for their operational process?
Again, I'm grateful that my product managers are pretty connected with what we do, so they do understand what we're doing, and there's definitely a lot of knobs that they can turn. But yeah, that's always about making sure that they do understand what the knobs control actually, and yeah, possibly or hopefully making as few knobs as possible
Sure.
to some extent.
And do you have any thoughts with the goal of promoting niche content? At some point, maybe you have to give up and say, okay, this was niche. We tried it, but no one cares that, you poured cream into the coffee and it looks like a famous person. This just isn't catching on. How do when to kind of promote niche or when to say you've tried it enough?
Yes, there's definitely some ceiling that we have to set, some amount of exposure after which we just say this item is not getting any attention, so we just stop recommending it. And this is also one of the knobs that the business has to turn and decide what is the right number. But then again, this number can be derived from the data, like you can put the numbers together and come up with some reason number.
Well, we've talked about the conceptual approaches and some of your objectives. Could we get more into methodology? What are some of the tried and true algorithms, or maybe you built something in house? What are you guys using, broadly speaking, under the hood?
Right. Well, in order to find the right users for given item, we actually did have everything we needed already at our hands. We have decided to repurpose the retrieval model of our four-stage recommender systems, which is a framework of how recommender systems look like from broader view, and it consists of 4 stages. First one of them being retrieval, and its purpose is to pre-select some smaller number of candidates that might be promising to the user, and then rest of the recommendation pipeline follows. And this retrieval model that we use is TensorFlow Recommenders library. And this model can be used almost directly to inverse the recommendation and to look for the right users for a given item. It's just about the two-tower architecture is based on embeddings, where an item and the user gets embedded into the same embedding space. And then the recommendation is done by searching for the items with the highest dot product between the most similar items to given user. And if we inverse this approach, we just look for the most promising users given an item.
This is actually one of the first times I've encountered that notion of we're going to recommend the user to the item. Is it easy to kind of invert the code, or were there a lot of hoops to jump through to make that path work?
It was the change in the code was just few lines. Basically, it's just that we changed what gets saved into the index that is used for searching. That was pretty much it. Yeah.
Well, I guess good confirmation that the two-tower approach is firm ground to stand on. So we talked about retrieval as, I guess, stage one, and I think you said there were 4 stages. What else happens?
Oh yeah. So after the retrieval stage, there is possibly optional stage of filtering. At this stage, we filter those candidates generated in the retrieval stage, and we remove possibly the items that the user has already consumed or that the user has already been recommended a few times and did not click them, so we don't want to recommend them again. We also may apply some other filtering, such as some spicy content before 10 p.m. and stuff like this. In the third stage, which is called scoring, that is where the main magic happens. That's where the main recommender model is used, and it's used to score those pre-selected candidates, and with some score with probability of clicking, or in our case, we do multitask learning, so we also predict the time that the user is going to spend consuming the item. And at the final ordering stage, we combine those multitask outputs and possibly apply some other business logic, such as maybe punishing some clickbait items to lower their score, just not to expose too much clickbait items, and possibly some other business logic. In our case, we also do include some diversification just to make the recommendation more diverse.
Makes sense, yeah. Well, you've obviously hit some milestones in the work to date, but I'm curious if there's anything ongoing or things you're excited about that'll come next. Where's the project going?
Thanks to me being invited to this podcast, it kind of stirred things up, and we are finally going to try content-based approach. That's because in the two-tower architecture, the embeddings are trained based on the user item interactions. And the main problem of this solution is that for those niche contents, those embeddings may lack the needed information. They may just be too bad, and the relevance of the user item pair might not be perfect. And if we replace those embeddings instead of the trained ones, trained on user item activity, if we replace those with content-based embeddings, back when we were working on the project, we didn't have good enough content embeddings for Czech language. Now we do. We could just switch those embeddings to content-based embeddings. And by doing this, we should be able to hopefully increase the relevance and also to breach some problems that arise, like that we need to reiterate. It has to be done. We have to wait for the item to gain at least some interactions, and only after this we can this item into the inverse recommendation. So after replacing the embeddings with the content-based embeddings, we will be able to just generate the right set of users right at the very beginning after the item has been published.
Very cool. Are there other projects you're working on, or is this your main focus?
As I've been talking about, content-based recommendation is currently in my focus, and trying to come up with the right way to create some content-based user profile, possibly consisting not of just like one embedding of the user, but users typically have more than just one interest, so we should naturally have more embeddings of a user that would somehow capture the interest of the user, and then use those to make content-based recommendation.
Definitely an exciting approach, an area to be playing around in. Do you have any thoughts on what complete looks like if you built the perfect recommender? There's this sort of story, I think someone who was working on the Amazon recommender, they said one day we'll build a system where you'll visit Amazon's homepage, there'll be a single product and you'll buy it immediately.
Mm-hmm.
And I mean, maybe it's a little silly or tongue-in-cheek, but what does the asymptote look like for you?
Mm-hmm. Yeah, so my perfect recommendation from my point of view as a recommender systems researcher would be, well, it probably would be similar, at least visually similar to what we already have, but there would be more imminent reaction of the recommender system. Once I interact with the item, maybe I would get a sequential recommendation, and the system would immediately understand what is my goal of this visit, whether I want to consume news or I just want to have fun and read some light reading article, or maybe I'm interested in something technical at the moment. So yeah, that's what a perfect recommender system should immediately find out by itself and serve me the right content.
Good observation for sure. And is there anywhere listeners can follow you online?
More official accounts, that would be my LinkedIn profile, Václav Blahut.
Sounds good. We can put a link in the show notes there.
Perfect.
Václav, thank you so much for taking the time to come on and share your work.
Oh, it was a pleasure and an honor to be invited to talk about at your podcast.
It was great chatting with you.